In this video, we'll be finding the inverse of this matrix here, and I'll be doing it by setting up an augmented matrix where you have the identity on the right-hand side, and the goal is to get the identity on the left-hand side. And when you have that on the left, the values on the right then are the inverse matrix. Now, a lot of calculators have built-in functions that can solve quickly for inverses of matrices, and if your calculator has one, I encourage you to use it. Calculators are great tools and should definitely take advantage of them if they can solve complex computations like this for us. So the goal here is to get this over here. So I'm just going to change this first value. I need it to be a 1. And to do that, I could divide everything here by 3, but then that's going to give me some fractions. Instead, I'm going to add row 2, the opposite of it. So make everything in row 2 negative and add it to row 1. So you can add multiples of any row to a different row, and that changes that row you're adding it to. So a -2 and a 3 makes a 1. A -9 and a 3 would make a -6. The 0 and a -4 added together would still be -4. And I'm not done yet with that addition, but I'm copying down the rest here because we need to add these parts in too. So a 0 plus a 1 is still 1. A -1 plus a 0 is -1, and then 0 and 0. So row 1 has changed. No other row has changed. And I have my goal here of a 1, 1 right there. And you should work these one column at a time. And so I next want to get a 0 here. To do that, I'm just going to go ahead and add row 3 to row 2. And so let me just copy down row 1 because it's not going to change. Row 3 is not going to change. But I'm adding row 3 to row 2 and changing row 2. So that's a 0. -4 and 9 is a 5. 5 and 0 is a 5. 0 and 0. 0 and 1. 1 and 0. So you can see there's a lot of addition here, plus and minus signs. There's a lot of opportunity to make a mistake, so you need to really go slowly and carefully through these. It's another reason why I really encourage a calculator, because it's not going to make any simple mistakes with addition or the signs. So next I need a 0 right here. If I do 2 times row 1 and add it to the -2, the 2 and the -2 will give me a 0 there. So I'm just making a note that row 1's not changing. Row 2 is not changing. All right, but 2 times row 1, so I'm going to have a 2 and a -2. That gives me a 0. I'm going to have a -12 plus a -4. That gives me a -16. I'm going to have a -8 plus a 5. That gives me a -3. A -2 plus 0 gives me -2. A +2. Oh, sorry, I messed up there, didn't I? See, it's really easy. So I'm multiplying by 2 here. So a +2 plus 0 gives me a +2. And then a -2 plus 0 gives me a -2. And a 0 plus 1 gives me 1. All right, so row 1's done. Now I want to make this a 1. And then once I get that to be a 1, I'll make that a 0 and that a 0. So I'm actually going to divide this entire row by 5. So as long as you divide everything in the row by the same value, it's a valid operation you can do. So that's going to give me a 1, a 1, a 0, and now I'm getting some fractions over here, which just makes the arithmetic you get a little bit more complex. Just got to pay attention to the fractions. 2, -2, and 1. All right, so now I can add 6 times this row to the top row, and I'll get that 0. So again, just making a note, the middle row is not going to change. and the bottom row is not going to change. But I am adding 6 times the middle row to the top row. So 6 times 0 plus 1 stays 1. And that's why we really want to do one column at a time, so that when we go forward with this, we'll always be adding 0 to these ones that we've locked in that we need on the diagonal, so they won't change. All right, and 6 times that will cancel out and give me a 0. That was the goal. 6 plus negative 4 gives me a 2. And then 0 plus 1 gives me a 1. And then here I'm going to have 6/5, and I'm taking away, or I'm adding to negative 1, which I can write as negative 5/5 plus 6/5 would give me 1/5 there. And then here, 6/5 plus 0 gives me 6/5. All right, so now I want to do 16 times this row and add it to the bottom. So just to write down my rows that aren't changing first. 6/5, 0, 1/5, 1/5. All right, so 16 times 0 and 0, that keeps my 0 locked in. That gives me a 0 there. And now I'm going to have 16 and negative 3. That gives me a 13. And then I'm going to have 16 times that plus 2. So 0 plus 2 is 2. And then 16/5. And so let's do our fraction addition here. We're going to have 16/5. And then a negative 2 would be negative 10/5. So we're adding those together. We will get 6/5. And again here, this will be 16/5, but it would be a positive 5/5, which would give me 21/5. And so making a little more room over here, proceeding, I need to get a 1 here. So I need to divide everything by 13. So I'm not changing row 1. Or row 2. And then row 3 is going to give me the 1. So now I have these perfect 1 down the diagonal. I just need to make these both 0 and I will be done. Now I get 2 over 13 here. So 6 over 5 divided by 13. When you do that fraction division, essentially you just need to know what 5 times 13 is. It's 65. So I have 6 over 65. And then 21 again over 65. So dividing those fractions by 13 makes the bottom 13 times bigger. So now, if I add the opposite of this row to this row, those will cancel out, and I'll have that 0 where I need it. So I'm not changing the top row. And I'm not changing the bottom row. All right, so what is getting changed is the middle row, and 0 is still 0, 0 and 1 is still 1. But the opposite of this will cancel out and give me that 0. The opposite of 2/3 plus 0 is negative, sorry, 2/13, negative 2/13. The opposite of this, well, 1/5 is the same as 13/65. So if I have a negative 6 of them and then I add 13 more, that's going to give me a positive 7 65ths. And then here I have a negative 21 and a positive 13. So that gives me a negative 8 65ths. All right, so now the last spot to get is right there. I will go ahead and clear some space here so we can do it nice and large. We're not changing the middle row. We're not changing the bottom row. And so these values over here aren't going to change either. 7 over 65, negative 8 over 65, 2/13, 6/65, 21/65. All right, so I need to multiply -2 times this row and add it to that. So those first two values don't change because we have zeros, and that last one becomes a 0. So we have our identity matrix that we wanted. And now I'm doing -2 times what I see here. So that would be, let's just go ahead and clear out more room. That would be -4/13. And I'm adding it to 1, which would be 13/13. So that gives me 9/13. Here, -2 would be -12/65. I'm adding it to 1/5, which we said was 13/65. So that gives me 1/65. And then here I would have -2 would be -42/65. And I'm adding it to 6/5. That's 6 times 13 um, is 78. So that's 78/65. And then 78 minus 42 gives me 36/65. And so we have our solution there, but I do want to just emphasize how great calculators are. Um, let me, showing here with an online calculator, of course your handheld one would be different how you input it. But most of them do have some sort of built-in matrix ability, and you enter in your matrix and push whatever you need to get it to know you want the inverse, and it can do all that work pretty instantly for you and not make, there's no risk of a simple mistake that can throw your answer off. So you do need to understand how to use the inverse and what it can be used for, but if you can get your calculator to do this, there's no reason to spend all the time and energy working it out by hand, especially when we start getting fractions and these more complex computations.